So for scenario B, a boat moves with a constant speed of 5 meters per second for a time of 4 seconds. The boat then moves at a speed of 2 meters per second for 4 seconds, and then does not move for 3 seconds. So if I look at my amount of time that's in here, I have 4 seconds, I've got 3 seconds here, and I've got another 4 seconds here. So 8, 9, 10, 11 total seconds. And so I'm gonna put on my time axis first on both graphs, since the time on a position versus time and the time on a speed versus time, if they're showing the same motion, should be the same. So if I have 11 seconds here, unfortunately my graph is only a 10. So if you are working on graph paper, you can extend yours over and have 11 boxes. I am going to pretend that I have 11 boxes and go up what I did before. So 2, 4, 6, 8, 10, and then again on yours, you should in fact have 11 boxes. My little grid system here only has 10. All right, now when I look at speeds, my speeds here, I've got 5, I've got 2, and then does not move, so a speed of 0. So if I'm gonna label the y-axis velocity in meters per second on this graph, I need to go up to 5. So I'm going to go 2, 4, 6, 8, and 10. Actually, forgive me, sorry. I'm going to go up by ones. This will allow me to use more of my graph. Okay, now, if I'm traveling at 5 meters per second for 4 seconds, I start at 5 meters per second at 0 time. 4 seconds later, I am still traveling that speed, and I should connect these with a straight line. Then I move at 2 meters a second for 4 more seconds. So from 4 seconds in until 8 seconds in, I'm at a speed of 2. I'm going to connect these with a dotted line. And my last bit of motion, I do not move for 3 seconds. So from 8 seconds to 11 seconds, I have a flat line at 0. And I'll connect those with a dotted line. Now, in order to transition this into a position versus time graph, I need to calculate the area underneath each of these. So I'm going to highlight for you. So this segment of the graph, if I take the area of this, I will then know how far I travel for section A. For section B, if I take the area of this segment of the graph, I will know how far I travel. So let's start with the yellow section, section A. And for section A, I have a height of 5 and a width of 4. So 5 times 4, I travel a distance of 20 meters. For B, I have a height of 2 times a width of 4. So 4 times 2, I travel 8 meters. For section C here, it's flat at 0, meaning I travel a distance of 0 meters. I'm going to add up my totals here, so 20 and 8 and 0, giving me 28 meters that I travel in general, or in whole in this graph. So now if I take a look at my position versus time, I'll label my y-axis here. Position is in meters. This is a position versus time graph. This is a velocity versus time graph. And so for 28 meters, that means I need my axis here to go up to 28. The reality is it'll probably go up to 30. So let's see here. If I go up by 5, so 5, 10, 15, 20. Let's go 5, 10, 15, 20, 25, 30. And it's gonna go up a little higher than I need it to, but that's okay. Now I'm going to go back to my red pen. In the first 4 seconds, I travel 20 meters total. So I start at 0, 0. 4 seconds later, I have traveled 20 meters. I'm going to connect this with a straight line. You should always use a ruler so yours is nice and straight. In section B, I travel 8 more. So after 8 seconds, I've gone 8 more meters, meaning 20 plus 8 gets me to 28. So I'm going to put my dot here. Oops. We're all over the place here, sorry. Okay, so I've got my dot after 8 seconds at 28, connect that with a straight line, and then I don't move in my last 3 seconds. So at 11 seconds, remember I'm off the graph a little bit here, you should be on the graph. I should have a nice flat line, meaning I'm not moving anymore. And that's your position versus time graph and your velocity versus time graph for scenario B.